In this example, we're going to use base blocks and algorithms to divide whole numbers. Use base blocks to determine 564 divided by 4. So let's start by representing 564 with base blocks. So we have 5 flats, six rods, and 4 units. Now we're going to use the 4 bins below to show how we partition the base blocks into 4 equally sized groups. So we're going to use the fair sharing model. We don't want to think of how many 4s are in 564. That could take us a while. Instead, we're going to break 564 into 4 equally sized groups. We're going to start with the largest place value, and we are going to give every group 1 flat. So I'm going to put 1 flat in each one of these bins. And then we get to this 5th flat. Okay, so we need to break this up, so remember we want the same amount in each one. We want a fair share, so we're going to break this flat into 10 rods. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right now we have a total of 16 rods to break into 4 equal groups. So notice, if we divide 16 into 4 equal groups, that would be 4 per group. So, do this in a different color. So, there's 4, there's 4, there's 4, and here's another 4. So, I'm going to put 4 rods into each group. 4 here, we'll put this 4 here, this 4 here, and finally this 4 here. So now we've equally distributed all of the flats and all of the rods. We're left with 4 units, and we can just put 1 unit into each group. 1, 1, oops, that should be an X. So now we've used all of the base blocks and we've shared them equally into 4 groups. Each group has the same amount, and to determine that amount, we'll look at how much is in one group. So we have 1 flat, 4 rods, and 1 unit. So 564 divided by 4 is 141. Now again, this was a long process to divide, but we use this basic idea when we use our algorithm for division. So let's look at the next slide, and we're going to see how we can connect this to an extended algorithm. So when we set up a division, you might remember this as long division. A long division problem, we write 564. We put this line in this bar, and we put the divisor, the number we're dividing by, out here, and this number is the dividend. So think about how we started with the base blocks. So we had 5 flats or 5 hundreds. And we wanted to break them into 4 equal groups. Okay. So each group got 1 flat. So that would be 100 per group. So this is group 1, 2, 3, 4. Okay. And that's a total of 1, 2, 3, 400 that we can subtract off. Now we have 164. Then we said, well, this is 10 rods. And then we also had another 6 rods, totaling 16 rods. And in terms of this, we could say 4 goes into 16 how many times? Well, it goes in 4 times. Sharing these 16 rods among 4 groups is 4 rods each. But remember, 4 rods is 4 tens, so that would be 40. And then we'll subtract off the 160. the 16 rods that we've distributed. And we have 4 left. And then finally, that 4 we had left, those were units. And 4 divided by 4 goes in 1 time. So each one of the bins got 1 unit, and we subtracted that off. And we had 0 left. So our result was 100, 140, and 11, which is 141. Okay. So this may look somewhat familiar to the standard algorithm for division that you learned for long division. So now let's see how we can streamline this approach. So we're going to set up 564 divided by 4. And what we do when we do this process is we just think in terms of single or maybe double digits, and we don't concern ourselves as much with place value, but we do line up our numbers in the appropriate place value spot. So you would say 4 goes into 5 how many times? Well, it goes in once, and you put it above the 5. Then you would subtract off the 4. 5 minus 4 is 1. Okay, so putting the 1 here, lining it up in the hundreds place, means that it's the 100 we had from our extended algorithm here, although we're not thinking in terms of hundreds right now. So once you subtract, you bring down the next number. And now we say 16 rods, or we think of 16, and we're just going to say 4 goes into 16 4 times. Now remember, this was really a flat and 6 rods, so this is 16 rods, but we don't have to go through that thinking with this process. We just think of it as 16. 4 goes into 16 4 times, subtract off the 16, and we have 0. You bring down your last number. 4 goes into 4 1 time, that goes in the ones place, and we have 141, just like we got here. So notice this is a little more streamlined, it's quicker, and you don't have to focus so much on the place value, but it accounts for the place value. And it's important you realize that there are place value concepts behind this algorithm that make it work.